So we're picking up with our discussion of the OSI model. We're going to pick it up at layer 3. Layer 3 is the network layer. Layer 3 controls communication on different logical networks, and this is where the abstraction between the physical and the logical comes into play. Layer 3 addresses are logical addresses that can be assigned to any type of Layer 2 device that supports the protocol that you're using. Now, for the purposes of this course, we're always going to be talking about TCP/IP. And IP is the Layer 3 portion of that protocol. And so you can probably figure out that the Layer 3 address in a TCP/IP network is the IP address. And obviously, if you've been around computers for any length of time and you've done any type of networking, you understand that an IP address can be assigned to whatever computer you want to assign it to. Again, it has to be unique, but I can take the IP that's on this workstation I'm currently using, for example, and if I wanted to assign it to my laptop, I could turn off this workstation, assign that Layer 3 IP address to my laptop, and it would enjoy the same network access that this workstation does with respect to firewalls and other Layer 3 inspection. Routers are the type of devices that operate at Layer 3. They look at the Layer 3 addresses. They don't care what the Layer 2 address is. They see you're coming from this Layer 3 network. You need to get to that Layer 3 network. I have a route to get there. You need to go out this interface. Not just for the purposes of this course, but in general, IP is the most common Layer 3 protocol you'll find out there. Whether it's IPv4 or IPv6, which we won't really get into IPv6 pretty much at all in this course, both of those are Layer 3 protocols. The type of applications you'll see running at Layer 3 are ICMP, ping, traceroute, RIP, because all of those really only care about getting the data to the remote network. It doesn't have any higher level functions other than can I get any traffic at all to the remote network, like ping. Ping is technically ICMP, just like traceroute is technically ICMP. It's different methods of using ICMP, and again, we won't get into that in this course. But it's an important distinction to draw out that a lot of people think, well, if I can ping the remote host, I must be able to do anything I want to the remote host. All you're guaranteeing with that traceroute or that ping is that you have a Layer 3 connection to the remote host. You could have services on that remote host that might not be responding, but again, I'm getting a little deep and a little further afield than I need to be. Let's move on to Layer 4. Layer 4 is the transport layer. It is responsible for end-to-end connection reliability. It performs this end-to-end connection reliability by breaking the network traffic into segments that can be retransmitted if needed and if the protocol supports it. Layer 4 is also responsible for byte orientation, flow control, and reliability, which we've already mentioned. So your transport layer can actually throttle your connection should you have quality of service or class of service rules in place for network transmission speeds. The type of protocols you'll see at Layer 4 are TCP and UDP. If you've been around NetWare, you'll recognize SPX, which is the Layer 4 component of IPX/SPX, and ATP, which is an Apple file sharing protocol. Moving right along, Layer 5 is the session layer. Layer 5 manages communications between two distinct endpoints, and it is different from Layer 4 protocols. Layer 4 is really concerned with the flow of the data. Layer 5 is concerned with the applications that use the Layer 4 data flows. Layer 4 gets you there. Layer 5 actually transacts business between two computers. If you've ever used any application that does RPC or remote procedure calls, Layer 5 is where RPC lives. Protocols that live at Layer 5 is L2TP, the Layer 2 tunneling protocol used by some VPNs. NetBIOS, again, if you've done any Windows networking at all, you know what NetBIOS is. PAP, which is the PPP authentication protocol. And PPTP, or the point-to-point tunneling protocol, which is another type of VPN connection. Layer 6 is the presentation layer. The presentation layer basically translates between different encoding methods, and the big example that all of the documentation and all of the classes use is translating between ASCII and EBCDIC, which IBM mainframes use EBCDIC, and PCs all use ASCII. The type of protocols you'll see at Layer 6 are AFP, the AppleTalk filing protocol, NCP, which is the NetWare core protocol that actually still exists with the non-IPX version of NetWare, if you're interested in all that, and Telnet, which basically just spits data at a remote host, and Layer 6 is where that translation takes place in the Telnet client. Layer 7 is the application layer. The application layer presents all of this network data that we've broken up into these segments and frames and packets and bytes. It presents it to the application or the end user on the specific endpoint. Protocols that you'll see at layer 7, HTTP, FTP, SMTP, SNMP, these are all the high-level protocols that you're used to dealing with. I make an HTTP request to the remote system, it spits me back a reply. I send an FTP packet to the remote system, it comes back and says, yes, I've received it, or here's your file, depending on which way it's going. You don't really care about how the data gets there, what IP address, so on and so forth. All you're saying is, that remote machine over there, I want it to get this SNMP packet, and it gets it. And that concludes our discussion of the OSI model.